Hi everyone. This week I wanted to give you some extra practice that's going to help you learn how to use the financial calculator that we're going to use for time value of money. So the first thing I need you to do is to log into My Finance Lab. When you get to your home screen, you're going to go down to where it says Financial Calculator on the left. You're going to click Financial Calculator. And then you're going to go to the My Finance Financial Calculator. You're going to open it up. And then we're going to walk through how to do some of those practice. So I have some practice pulled up. Those practice are also available in your weekly folder under week 4, extra practice from video. So you can find those, open that Word document up so that you can look at them along with me. All right. So here are the problems, and I also have the calculator shown simultaneously so that I can show you what I'm doing as we go through and do them. So there are 8 time value of money problems here, and once you've read through the materials, this is a great idea to go through and do some extra practice. So for this week, we have 4 formulas that we're using. We have the future value, the present value, future value of an annuity, and present value of an annuity. The hardest part with a problem is knowing which formula to use, so you have to look for keywords, and we'll go through them as we do the problems. One of the things we're going to need to remember is the calculator and how to use it. So I'm going to go over here to the right and look at the calculator. The first thing you want to do anytime you're keying it in is hit this reset button. So before you do any problem, you're going to hit reset. You'll see some other buttons that we need to go over. So we can see that we have this N. This is for the number of periods. We have I/Y. This is for the interest rate. PV. This is for present value. It's important to notice that anytime we have to key in present value, we always key it in as a negative number. We have the PMT button that we're going to use for annuities. And then we have future value button. So the other thing I want to point out is we also have up here CPT for compute. When we get into the next chapters 8 and 10, we're also going to be looking at these cash flow, NPV, and IRR buttons. So we'll go into them later. But for now, we're just going to hit reset so that we know that we've cleared everything out. And then we're going to get into our first problem. So our first problem over here to the left says that assume that you purchase a 6-year, 8% savings certificate for $1,000. If interest is compounded annually, what will be the value of the certificate when it matures? So we have to figure out, what is it asking us for? Well, it's telling us that we're going to purchase a savings certificate that's going to cost $1,000. We're going to let it sit for 6 years and accumulate 8% interest annually. So if it's compounded, what is going to be the value at the end of that period? So we're looking for a future value. It's not an annuity because we don't have payments going in or multiple cash flows. We just have one time that we're buying this. So we have one cash flow, that $1,000, and then we're letting it sit for a period of time. So this one is going to be a future value problem. So we had to look up some information. So we need to know what is the number of periods. We need to know what is the interest rate. And then what is the present value? Because if we look back at our formula, it is future value equals present value times the interest factor, or FVIF, for a certain rate and time. So that's the formula we're looking for. So our number of periods, it says it's a 6-year, so we have 6 periods. It is 8%, and we're going to pay $1,000 for it. Now remember, we're keying in all present values as negative, so I'm going to write that here. Now we go over to the calculator. This is what we're going to enter. We're going to just kind of go in order. So we're going to hit reset. We're looking for 6, and then we're going to hit N, and then we can see that up here, number of periods went to 6. We're going to hit 8, and then I, And we can see that our interest per year is now 8%. We're going to hit 1,000 as the present value. Remember, we have to key in a negative. We're going to hit PV. And then we're trying to solve for the future value. So we're going to go up here to this compute and then future value. And we see that our answer, the future value, is going to be 1586.87. And that's all there is to it. So let's look at the next problem. With our next one, we're using the same information, but it's saying that it's compounded annually. So what changes? Well, with semi-annual interest, that means that there are twice as many periods because it's being compounded every 6 months, so 2 times a year. So if there are 6 years, we multiply that by 2, and we're going to have 12 periods. If we have interest that is annually 8%, then we're going to divide that by 2 because we're going to get half every 6 months. So it's going to be 4% semi-annually. And then our PV doesn't change. So we have that negative 1,000. Now if we go over to the calculator, we hit reset. We enter in 12 as our N. We enter in 4 as our interest. We enter in 1,000 as our present value, which means we have to enter a negative, and then PV. Now we hit compute future value. And our answer for this one is 1601.03. So what this tells us is just by getting the semi-annual interest instead of annual, we're making that much more money. All right, let's look at the next problem. So number 3, it says a friend promises to pay you $600 2 years from now if you loan him $500 today. What annual interest rate is your friend offering? So this one, we're actually solving for the interest rate. We don't know what the rate is, but they're telling us the present value is 500, the future value is 600. They're saying 2 years, so we can use future value to solve. And we're going to be looking for N is going to be 2 years. I is what we don't know, so that's our unknown. And our present value was 500. Remember, we have to enter it in as a negative, so that's what I'm going to do. Our future value equals 600. So now we're going to go over here, we're going to hit reset. We're going to enter in 600 future value, 2N. We don't know I, so we can't enter it in. We're going to enter in 500 for present value, which means we have to enter a negative. And then we're going to hit compute I, and it's going to tell us what the interest rate would be. So interest rate would be 9.54%. So you can solve for the different factors as long as you have enough information to do that. So let's look at our next one. Our next one, we have number 4. It says you decide to begin saving toward the purchase of a new car in 5 years. If you put $1,000 in a savings account at the end of each of the next 5 years, the account is paying you 6% interest. It's compounded annually. How much will you have after 5 years? All right, well, like I said, there are some key words. So one of the things is telling us that we're making payments more than one time. We're making a $1,000 payment at the end of each year for 5 years. So we're making 5 $1,000 payments. So that means it's an annuity. So it's asking us how much will we have. So what is the future value of an annuity? That's what we're solving for. So we have to look up N, which is going to be 5 years. Our interest rate is 6%. And our payment, because if we look at the formula for future value of an annuity, it's PMT times future value interest factor for an annuity for a certain rate and time. So our payment amount is $1,000. So we're going to go over here to our calculator. We're going to hit reset. We're going to enter in what we know, and we're going to solve for that future value of an annuity. So we have 5N, we have 6I, we have $1,000 as a payment, and we're going to compute the future value. And there we can see that our future value is 5637.09. All right, let's look at number 5. Number 5, we're going back to the same kind of thing, except this time we're putting $500 in every 6 months instead of $1,000 per year. So we have to look at how that changes our numbers. All right, so we have still future value of an annuity that we're solving for. This time it's semi-annual though, so we have to factor in. We had 5 years. Oh, sorry. We have 5 years times semi-annual, so that's 10 periods. Our interest rate is 6% divided by 2 because it's semi-annual, so you're getting half every 6 months. So it's 3%. And our payment is now $500. All right, so let's go over and see how that affects our numbers. We're going to hit reset. We're going to enter in 10N, 3 interest rate, 500 as our payment, and we want to compute the future value of an annuity. And our future value is going to be 5731.94. All right, number 6. Number 6, it says, what is the value today to be received at the end of 8 years? Assume a required rate of return of 7%. So, what is the value today? Present value. That's what we're looking for. If we have 8 years at a rate of 7%, and we're looking the future value is 1,000 because it says what is the value today of 1,000 to be received. That's your key word. That is telling you that it's in the future. So $1,000 that you're going to receive in 8 years. All right, so let's key that in. So we have 8N, we have 7I, we have 1,000 as our future value, and we're going to compute that present value. So we'd have to put in 582.01 to get $1,000 in 8 years if we let that 582.01 sit there for 8 years and earning 7%. All right, let's look at our next one, number 7. All right, number 7, it says, how much would you be willing to pay today for an investment that would return $800 at the end of each of the next 6 years? Assume a discount rate of 5%. All right, so this one is looking for the present value of an annuity. So we're going to be N equals 6, I equals 5. Our payment amount is 800. So if we go over, we try to solve for that. And again, annuity because it says at the end of each year. So we're going to hit reset. We're going to hit 6N, 5I, and 800 as our payment. And we're going to hit compute PV. And we get our present value of an annuity of 4060.55. All right, I have run out of time to do that number 8, so I will post that solution out there in the announcements. Thank you, and if you guys have any questions, please let me know. Have a good day.